All right, so let's do this problem. We're going to find the limit as x goes to -1 of that. Now, if I can plug in -1, that's the answer. You just plug it in and that's your answer. But I bet I can't plug it in. And how can I know? I can know because I can factor this. Let's factor the top and bottom. It's always good with this is a rational function. It's always good to factor it. So that's going to be x
There's a whole, right?
minus 5
x plus
and
1.
x plus 1. And I bet there's going to be an x plus 1 on the top too. How I know that?
Because it asks for a removal of discontinuity.
I know it because, well, that's just usually what happens. So let's see if it works. 2x minus 3. Does 2x minus 3? If I multiply, if I FOIL this top back out, does it give me that 2x squared minus x minus 3? Mm-hmm. It sure does.
Yes,
And
it
that's
does.
how I knew. All right, so what's my whole? What's my removal discontinuity?
Okay, ask mañana.
-1.
Why are you guys arguing?
So the limit as x goes to -1. Notice that if I plugged in -1 to this right here, I would get 0 over 0.
Yeah.
When that happens, that means
There
there
is
was
a
a
limit.
hole there, and so it could have been factored. And now that I've gotten rid of that, when I plug in -1 to this one, I'm going to get 2 times -1, which is -2 minus 3 all over -1 minus 5, which is -5 over -6, which is just 5 over 6.
Exactly, so what
And the reason that is, so explaining that with rational functions, that means that the point -1 comma 5/6 is a hole in that function right there.
Yeah.
And if I were to graph this rational function, which would have, let's do that real quick because it's good practice. That's my what? 5 is my what?
Or sorry,
That's-
vertical.
It's my vertical asymptote, right? There's 5. It's my vertical asymptote. -1 comma 5/6, -1 comma positive 5/6, which is right here, is a hole. So there's a hole right there. What's my horizontal asymptote since the degrees are the same? The horizontal asymptote is the ratio of leading coefficients. Remember this?
Yeah.
So it's right there. 2. And, well, what's my 0? My 0, use the top, the numerator, set the numerator equal to 0.
3 over 2.
3 halves, very good. So that's 1.5 is my x-intercept, so it's right there. I'm going to do this in red now. There's my x-intercept right there, 3 halves, right? Did I do that right? Everybody? Yes?
Yeah.
And now, so my graph's going to do this. It's going to go down there. It's going to go like that. That's going to be my left side of my graph is going to be like that. And my right side, it's got to be up here. How do I know it's got to be up there?
Because there's no x-intercept.
There's no
Man,
x-intercept.
someone is smart. Because there's no other x-intercept. If it was down here, it would have to do what?
Go dip down.
It would have to go through the x-axis again. But you know there's only one x-intercept, which means by default the graph has to be up there. Why can't the graph be up here?
Because of the horizontal
Restriction.
asymptote.
Because then it wouldn't be a what?
Function.
Yeah, and that would be silly because you know this is a function. It just can't. You can't have it like that. That's ridiculous. Why would I even
So
think
bad.
that?
Ridiculous.
But a lot of people do think that. They're like, well, why can't it be there? And I'm like, because it's a function. And then I go into this whole discourse about functions and I explain why functions are awesome. All right, got it? Do you have another
Squire
question?
puts the fun in
So you got
function.
3 halves by saying 0?
You
I
just
got
plug in. You just plug in
3
0 for
halves
the thing.
because the numerator has to equal 0 for the x-intercepts. So just set that equal to 0.
The numerator?
Yep, the numerator
And
is
the
equal to 0. Remember, this is no, the denominator is
Denominator's for your
vertical
vertical
asymptotes.
Wait, no. What are we talking about?
Boys.
I thought we were talking about.
Boys. All right.
Mr. Dwyer, I'm going to head out because my